Chapter 8, Section 6 is on dividing radicals, and today's process is called rationalizing the denominator. And when we need to do this is when we have a fraction, when we have the square root on the bottom. Okay, so mathematicians are weird, and they said that it's not okay to have the square root on the bottom. Okay, so we have a process so that we can kind of get rid of that. Okay, so first example is 12 over 6 times the square root of 3. Well, before we even begin, okay, kind of treat the square root of 3 like a variable at this point, and then realize that 12 over 6 will reduce, so that will give me 12 over the square root of 3. Okay, if you can reduce before you even get started, it's going to make your life a lot easier. Okay, now the whole process of rationalizing the denominator means I'm going to multiply the top and the bottom of this fraction by the square root of 3. Okay, and whatever is down here, okay, in your denominator is what you're getting rid of, and that's what you're going to multiply by. Okay, now remember you multiply straight across. So that's going to give me 2 times the square root of 3 on the top, and then the square root of 3 times the square root of 3. Okay, the whole point of this, let me write this for you. Square root of 3 times the square root of 3 would give me the square root of 9, which is just 3. Okay, so it cancels the square root out. Now I don't have the square root on the bottom, I have the square root on the top, so life is good. Okay, all right, so we'll try example B. I've got 25n over the square root of 15n. Okay, so just like I did before, the problem is down here. So to get rid of the problem, I'm going to multiply the top and the bottom by the square root of 15n. Okay, and remember you multiply straight across. So you kind of just put that number that was originally there in front. So I have the square root of 15n here. Okay, now again, on the bottom, square root of 15n times the square root of 15n, the square roots just cancel, so I just get 15n. Okay, now again, treat the square root of 15n like a variable, which means you reduce around it. Okay, so when I reduce around that, that means my n's on the outside will cancel, and then 25 over 15 should reduce down to 5 over 3. Okay, and then just add back your label, the square root of 15n. Okay, so there's your answer there. You got rid of the square root on the bottom, you move it to the top, your goal is accomplished. Okay, part C. Okay, so I've got 16a over a times the square root of 64a to the 5th. Again, you're going to kind of treat this piece like a variable for now. See if you can reduce around it. So hopefully you realize that those a's cancel right off the bat. So now I've got 16 over the square root of 64a to the 5th. Okay, now before I try and get rid of it, hopefully you realize that the square root of 64 is perfect. Okay, so if I were just to simplify, again, I haven't done anything new, I'm just simplifying. The square root of 64 is 8, right? So that just comes out perfectly. And then if we are doing kind of our house trick from yesterday, remember that there's a 2 out there, so I can take 2 groups of my a's out, leaving me with 1a underneath. Okay, so the bottom becomes 8a squared times the square root of a. Okay, so we're basically just building on the skills from yesterday, nothing really too new. So at this point, you should see that 16 over 8, that reduces to 2 over a squared times the square root of a. Okay, and here's now that it's as simplified as possible. Okay, now I'm going to get rid of my problem. My problem is the square root of a. So I'm going to multiply the top and the bottom by the square root of a. And again, you multiply straight across. So on the top, I get 2 times the square root of a over. Okay, now be careful here. I've got a squared times the square root of a times the square root of a. Well, the square root of a times the square root of is a, and then times a squared means I have a to the 3rd on the bottom. Okay, so let me go through that again. The square root of a times the square root of a, this part just gives me a. I still had an a squared, so a squared times a gives me my final a to the 3rd. Okay, so my final answer, 2 times the square root of a over a to the 3rd. Okay, so a little trickier here, just go step by step again, don't rush this chapter. Okay, part D, hopefully I'm going to realize that I have a b here and a b here, so I can cancel one of those. So I'm going to start off with 7b over the square root of 27b to the 3rd. Okay, and here's where things get really fun. This looks just like yesterday's problem. So before I move on, I want to simplify this if I can. Okay, so I'm looking for a perfect square that breaks down 27, and 9 breaks that down evenly 3 times. Okay, and then I still have the square root of b to the third. Okay, so again, just like yesterday, the square root of 9 is 3. The square root of 3 is 3. Okay, there's really a little 2 out here. Mom says you have to go outside in groups of 2. So I've got 1b and then 1 left inside. So this whole bottom, okay, again, all I've done so far is simplify. Top part is 7b, and on the bottom, I've got 3b times the square root of 3b. Okay? Again, I'm still going to simplify here. I'm going to notice that one of these b's can cancel with one of those b's. So I've got 7 over 3 times the square root of 3b. Okay? Also important that you realize that you're only getting rid of your problem, and that's the square root. So all I'm going to do is multiply the top and the bottom by the square root of 3b. Okay, again, you're multiplying straight across. So I have 7 times the square root of 3b over, again, be careful down here, write it out if you need to, 3 times the square root of 3b times the square root of 3b. Well, that part gives me 3b. I still had a 3, so this is over 9b. Okay, so 7 times the square root of 3b all over 9b is my final answer. Okay, so lots of steps, just take them nice and slow. All right, let's try another tricky one. Example E. Again, simplify first. Where should I write that? Here. Simplify first. Okay, big idea. Okay, so if I simplify first, I know that 8 over 2 is 4. I know that d squared cancels with one of those d's, so that becomes 4d. Okay, and then over the square root of 32d to the third. So automatically, that's a lot nicer. Okay, so now again, I'm going to see if I can break this down like I did yesterday. So I'm looking for a perfect square that breaks down 32. Okay, and that's 16, and 16 breaks it down twice. And then I still have the square root of d to the third. Okay, so the square root of 16 is 4. I still have the square root of 2. Okay, and then the house trick. So in groups of 2, so 1 can come out and 1 is left inside. So if I rewrite what I had before, I've got 4d over 4d times the square root of 2d. Okay, oh, this is getting nice. Now I'm like, hey, 4d and 4d cancel, so I've got 1 over the square root of 2d. Okay, always multiplying by your problem. So my problem is the square root of 2d. So multiply the top and the bottom by the square root of 2d. So the top I've got square root of 2d, and then the square roots cancel on the bottom, and then over 2d. Okay, so that wasn't as bad as maybe you thought. Okay, if you simplify first. Arrow, highlight, circle, simplify first. Okay, these are, believe it or not, the simple problems. Okay, the next ones get a little trickier. Okay, if you notice, because I have an area that's circled. And now what happens is the bottom, okay, has become more complex because there's either going to be a plus or a minus sign in there. Now, when the denominator is complex, we have to multiply by the conjugate, okay? And that is the denominator. Denominator, it's kind of like the Terminator, only you change the sign. Okay, so if I was going to simplify f, the denominator is 5 minus the square root of 7, so I'm going to multiply by the conjugate, so I'm going to multiply by 5 plus the square root of 7. And just like in the earlier ones, I have to multiply the top and the bottom by that conjugate. Okay, so whatever is on the denominator, okay, that's this part down here. If the circle, if whatever is in the middle is a minus, okay, you change it to a plus. Okay, again, you multiply straight across, but now you realize that you need to distribute. Okay, so the 9 needs to go to the 5 and to the square root of 7. So 9 times 5 gives me 45, okay, plus 9 square roots of 7. Okay, so distribute it to the 5 and the square root of 7. Okay, now on the bottom, we need to FOIL. Okay, first outside, inside, last. So 5 times 5, 25. Outsides plus 5 square roots of 7. insides minus 5 square roots of 7, lasts minus 7. Okay, now if you do everything right, these middle two, if you notice, will always cancel. And that's the whole point, so that we can get rid of the square root on the bottom. So my top stays 45 plus 9 square roots of 7. The bottom, now I have 25 minus 7 because the square roots cancel. Well, 25 minus 7 is 18. Okay, and then just like you did with imaginary numbers in the first semester, you're going to break these two, okay, into two separate. So I've got 45 over 18 plus 9 square roots of 7 over 18. Okay, so you separate it out. I think you guys called that the heart thing maybe. Okay, so just put the first part over 18 and the second part over 18. And then you should go ahead and reduce for me. Okay, so that's going to give me, divide by 3, 15 over 9 plus the square root of 7 over 2. And 15 over 9 should go down again by 3. So that would be 5/3. There we go. So 5/3 plus the square root of 7 over 2 is your final answer there. Okay, so let's try that again in example G. Okay, and I'm just going to slide this up so that we can see this a little bit better. Now I'm going to multiply first part, okay, by the conjugate. Let me erase some of this over here too, so that this isn't in our way here. Oop. Or maybe I'll just extend my page. That's even better. Okay, so I'm going to multiply by the bottom, okay, only changing the sign. So I'm going to multiply by the square root of 7 plus the square root of 5. Okay, and whenever you multiply the top by, you also multiply the bottom by. Okay, so multiplying the top and the bottom by the square root of 7 times the plus the square root of 5. Okay, so now I'm going to go ahead and I'm going to distribute the top. So that's going to give me 6 square roots of 7 plus 6 square roots of 5. Okay, don't forget to distribute up there. And then we're going to FOIL the bottom. So that's going to give me 7. Okay, square root of 7, square root of 7, 7. Plus the square root of 35 minus the square root of 35 minus 5. Okay, so just FOIL there. So simplify 6 square roots of 7 plus 6 square roots of 5. Okay, again, I probably did this right, or at least part of it, because those middle two cancel. So 7 minus 5 gives me 2. Okay, so when I break it apart, that gives me 6 square roots of 7 over 2 plus 6 square roots of 5 over 2. And then I can reduce my 6 over 2. So my final answer is 3 square roots of 7 plus 3 square roots of 5. And those cannot go together because the square root of 7 and the square root of 5 are different. Okay, so again, lots of steps here. Just take it one by one. Okay, and stop yourself. Think about what you just wrote down. Think about what you saw. Okay, and write some questions because I'm sure you have some.